Hi, hello, and welcome to the physics clinic. So today's topic is we will see the additional concepts of organic chemistry, basic organic chemistry. Okay, so in along with this homolytic and heterolytic cleavage, we'll see the basic concepts, more concepts. Okay, substrate and reagent we are going to see right now. So actually, in an inorganic compounds, you may have ions, right? Ions are not formed in a organic compound. So we usually name that particular thing as a reagent and a suppose that total reactants are substrate and a reagent. Substrate is where the new bond formation is appear by the reagent. So that is the substrate. Substrate is the compound where the new bond formation is formed. So new bond formation means covalent bond, right? So when carbon-carbon bond is formed, the choice of naming the reactants as substrate and reagent is arbitrary, we can say. So that means by really observing the formation only, we can able to say whether it is reagent or substrate. Otherwise, it is very hard enough to say substrate or reagent. Okay. So keep in your mind this point along. So when carbon is involved in new bond formation, so that particular molecule, so in the molecule whose carbon is involved in forming new bond formation, so that is called the substrate. Okay. So in this is substrate, bromine is reagent. Okay. So the product is formed. The same like substrate and reagent. So in this you have to understand what is the substrate and the reagent. Okay. So there we are going to study about the nucleophiles. Okay, so I will explain you the nucleophiles. Okay, so there must be intermediate products also. Here it is not given. When substrate plus reagent, so the substrate is attacked by the reagent, definitely formation of intermediate and finally the product that may happen. You can write that also. Will explain you. Yeah. So this is the mechanism of organic reaction. So what is the mechanism of organic reaction? Substrate plus reagent. It gives intermediate product, and then product. Okay. So this thing you have to keep in your mind. This is very important point. Okay. So then we'll see the remaining. So we'll see the next topic. So the next topic is we are going to see the nucleophiles and the electrophiles. Okay. So what are nucleophiles and electrophiles we are going to see now? Yeah. So you have come across in this chapter only very small portions are given. Okay. I'll give you a very brief detail. What is the nucleophile and what is the electrophile? Okay. Reagents attack the reactive site of the substrate. Right up. So reagents attacks the reactive site. Okay. Okay. So reagents attack the reactive side of the substrate. Okay. Reagents, definitely it is at the reactive sites. Okay. Then reactive site will be electron diffusion portion of the molecule. That means a positive reactive site. Okay. So if the site is positive reactive site, so that an atom with an incomplete electron shell or the positive end of the dipole in the molecule. Okay. So if the attacking species is electron rich, it attack these sites. Okay. So if attacking species is electron deficient, that reactive site for it is that part of the substrate molecule which can supply electrons. That is pi electrons in a double bond. I'll explain it again. Okay. So an attacking reagent is a species that reacts with a substrate molecule or immediate and produces a, or intermediate also we can say, produces a product. Okay, wow. There are two types of reagents, electrophile and nucleophile we saw. So what is an electrophile? Okay, so these are the chemical species. You don't think it is nothing actually. It is like a reagent. Reagent which is attacking the uh, site of substrate. Okay, if the substrate is electron deficient, electron rich nucleophile is attacking. If the substrate is electron rich electrophilic substrate, then the reagent is nucleophile. Okay, so electrophilic means electron deficient. Nucleophilic means actually speaking electron sufficient, like that. Okay, the substrate can be electrophilic. We usually call this name electrophilic or nucleophilic for the substrate. For the reagent, we can usually name that as nucleophile and the electrophile. Okay. So keep in your mind, what is electrophilic substrate? The substrate which is having electrophilic means what is that? Electron deficient. Okay. Electron deficient center. There, nucleophile is attacking. That means the reagent should be electron, more electron it should be there. Okay. So electron rich nucleophile is coming and then it is attacking the electrophilic center. The vice versa also happen. Okay. So electrophile, it comes from the word, we can say electro, which is derived from the word electron only. Okay. So phile means it is love. So electrophilic means love of electron. It is attacking the, I mean, the nucleophile is attacking in it. Nucleophile is rich in electron. So the vice versa also possible. So we know that what is an electrophile? It is not a foreign reagent. It is just a molecule, ion or atom that is lacking in electrons. So that is electrophile, we can say. Okay, electrophile is the electron deficient reagent, we can say. Electrophilic center is the electron deficient center where the nucleophile can attach. Okay. Okay. So electrophiles, we'll see some characteristics. Can you take down the characteristics of an electrophile? All of you. So what are the characteristics of electrophile? There are electron deficient. The nucleophile, I mean electrophile, you just write now. Okay. So what is an electrophile characteristics? You are going to write this. So these are all the electrophile characteristics. First one is, take down, they are electron deficient and have a strong attraction to electrons. So electron deficients and have a strong attraction to electrons. It is attracting electrons. Got it? Then they have either a positive charge or a neutral species. They have either a positive charge or neutral species. Okay. It is a molecule or ion. Okay, we consider. So it is an ion which is having positive charge. Then molecules also there, neutral species. Okay. Then they attack places with a lot of electrons, like carbon to carbon double bonds, for example. Okay. The third characteristics are they attack places with a lot of electrons, like carbon to carbon double bonds. Okay. Then the fourth one is the density influences electron transport. okay, which normally occurs from a high density to a low density location. So always, this is the nature, this is the law of nature. So here also the density influences electron transport, okay, which normally from high density to lower density location. Okay, that is the fourth point. Fifth point is electrophilic addition and electrophilic substitution process should be preferred under these reagents. That and all we'll see. What is an electrophilic addition means? In this electrophilic center, there might be nucleophile can be attached. Okay. So if it is added, then we can say. If it is substituted by some other thing, so that is electrophilic substitution. There are two differences. Okay. Then this processes definitely enhance under the reagents only. Okay. The fifth point is electrophilic addition and electrophilic substitution process should be under these reagents. Okay. So without nucleophile and electrophile, no addition and substitution reactions will be there. Okay. Is it clear? So what is the reason? Suppose if you're asked, like, what is the reason? Because they take electrons, okay? Because they take electrons, also known as Lewis acids, we can say. They are also known as Lewis acids. Okay. Then there are types of new electrophiles are there. Okay. So positively charged electrophiles, I'll give you some example. So these are all the positively charged. They act as a Lewis acid we saw, right? Types of electrophile. First one is positively charged electrophile. Okay. So you know that they are Lewis acid. They act like a Lewis acid. Okay. Example take down. H plus, NO2 plus, CH2 plus, NO plus. Then so many things you can take down from your book. Then N2 plus, then C2H5 plus, etc. Okay, you can take down so many things from Google also. Okay, so many examples. Okay, then neutral electrophiles. This is charged, positive charge. Then neutral electrophiles. What are the neutral electrophiles? Electron diffusion molecules having incomplete octet. So we know that electrophiles means you know that electron diffusion, right? Center or electron diffusion molecule, right? They are electron diffusion molecule having incomplete octet. These are all electron diffusion molecule having incomplete octet. Okay. Say for example, this is they involve Lewis acid also. This is also a kind of Lewis acid. What are all the example? BeCl3, then AlCl3, BeCl2, AlCl3, BF3, then SO3, CO2, zinc chloride, FeCl3, SnCl2, etc. Okay. So third one, free radicals also be there. Okay, free radicals example, carbene we can say, CH2, hmm? Free radicals. What is carbene? Carbene is CH2 alone. It is also having, I mean, it contains unpaired electrons like we can say it acts like a carbon act like a electrophiles. Okay. So example, nitrines also, nitrines and carbenes. Okay. Then, so we'll see nucleophile. Nucleophile is just a ulta or it is directly opposite to the electrophile. Right? So what are all the nucleophile? Nucleophile is electron rich species. What is nucleophilic center? electron-rich center where the electrophile can be attracted. Okay. It is having much electron, more electron, so that the electrophiles are attracted towards it. Electrophiles are deficient in electrons, so it is naturally attracted towards the electron-rich center. So nucleophilic is attacked by an electrophile. So nucleophile is attracting towards what? Electrophilic center. Okay. So these are also having some characteristics. Take down the characteristics. Electron rich, and are attracted to the nucleus. Okay. The first characteristics are nucleophiles. They are made up of electrons and are attracted to the nucleus. Okay. They are either negatively charged or neutral. Nucleophiles are Lewis base. Lewis base. So we can say what? It is negatively charged or it might be a neutral. Okay. So according to Lewis theory of acids and bases, we know that nucleophile gives unshared electron pair, that is the lone pair, okay, and act as a Lewis base. This is very important point. Okay. So this nucleophile gives unshared electron pairs. That means lone pairs. Okay. So that it acts like a Lewis base. Got it? So the second characteristic is they are electron donors. Electron donors. Nucleophiles, third one is nucleophiles always attack on the electron deficient side. That means electrophilic center. Okay. It also used in nucleophilic substitution and addition reaction. Okay. So we are going to see types of nucleophile. First one we saw negatively charged nucleophile, then neutral. Okay, then ambident nucleophile also there. So I will explain later. Okay. So first one, example, negatively charged nucleophile. Okay. Example, Cn minus, OH minus, all base, Lewis base, I minus or COO minus, then NH2, okay, then SH minus, OR minus, etc. Then neutral. These are all the examples. Neutral nucleophiles are, it is electron-rich species having lone pair of electrons, right up. So how the neutral will be? It has lone pair of electrons. Okay. There we saw in electrophile incomplete octet configuration. Here, lone pair of electrons are rich in it. Okay. So then, examples are NH3, H2O, etc. All polar molecules basically. Okay. Then, ambident nucleophiles. Third one is ambident nucleophiles. What is ambident nucleophiles? Some nucleophiles have a pair of electrons or two or more atoms, or we can say canonical forms. I've explained you in a resonance structure, right? So we saw already in chemical compounds also. So chemical bondings there also. So canonical forms, you can explain the ambident nucleophiles as the nucleophiles have a pair of electrons on two or more atoms. Okay. So, or canonical forms, we can say that two or more atoms might be canonical forms, can be drawn in which two or more bear an unshared pair of electrons. So, this is very important point. Nucleophiles which have attacked two attacking sites, that is one negatively charged and one neutral site, are known as ambident nucleophiles. What is an ambident? We can say already nucleophiles we can consider nucleophiles which have two attacking sites. In simple, we can say which have two attacking sites, one negatively charged and one neutral site. Okay, these are all known as ambident nucleophiles. Got it? Example I will give you. So, what is an example? NO. Okay. So, one is negatively charged site, another one is neutral site. Okay. So, two sides of attack we can say, right? O, N, that is, we can say, has two and N as one lone pair of electron respectively. Okay. So, O, N, O, right? So, it has lone pair of electrons. Okay. So, like this. So, we can say Cn also. Cn has two sides of attack. C triple bonded. It is also have two sides of attack. So this is known as ambident nucleophile. So only nucleophile we can see. Okay, wow. So these are the examples. Suppose if you are given any questions based on this. So take down the question out of this nucleophile and electrophile. The question number one is among the following X, do right? Among the following X is the number of electrophiles and Y is the number of nucleophiles. Report your answer as XY. Okay. So this is your question. Okay. So first option is H plus. Okay. So you are given among the following. So H plus, second one is I minus, third one is NO2 plus, fourth one CH2 plus, fifth one NH3 lone pair. Okay. So sixth one Br minus. So you are asked to find out XY, right? X is the number of electrophile, Y is the number of nucleophile. A option is 3, 2, B option is 2, 3, C is 3, 3, and D is 3, 1. Okay, so can you find right now? So what is the option? Which one is correct here? Okay, what is this H plus? H plus is nucleophile or electrophile? The plus sign itself it shows it is electrophile, right? So then what is I minus? The I minus shows it is nucleophile. Then what is NO2 plus? It is electrophile. Okay. Then what is this CH2 plus? It is also electrophile. What is NH3? It is lone pair. Okay, it is carrying a lone pair of electrons. It belongs to the category of nucleophile. Right? Then Br minus, obviously it is nucleophile. So out of this, how many nucleophiles? 3. How many electrophiles? Y is 3, X is 3. So 3, 3 is the correct answer. XY is 3. Clear? Like this and all, you'll be asked questions. So keep in your mind. So I will give you another question. Which of the following is an electrophile? Take down. Which of the following is an electrophile? The second question is, so I will give you the option. First, A option is CH3C plus double bond O. Then B option is AlCl3. C option is DH3. D is all the above. We are asked to find which of the following is an electrophile. Okay, can you find now? Generally, the positively charged species carries a positive charge, right? This is the central atom, it is having positive charge. So it is obviously, this is obviously electrophile, right? So it is electrophile. Okay. Then electron diffusion molecules we saw which is having incomplete offset of the central atom. That's what we used to see, like Lewis acid band, right? So what are all those AlCl3 also electrophile, BH3 also electrophile. Okay, electron deficiency. That is the incomplete octet formation. So the option is all the above. Okay, like this you will be given the questions. Okay. Mm, like this, you are given so many examples and you are asked to find the electrophile or nucleophile. Okay. So you'll be asked that reactivity order also, you might be asked. Okay. So the decreasing order of nucleophilicity among the nucleophiles, that is also asked. Okay. So that is based on how many electrons are donated. That means the tendency of donating electrons. Okay. So electronegativity period, from the left to right of the periodic table, the electronegativity period increases. Okay. The tendency to donate electrons also decreases. If the electronegativity increases, tendency of donating electrons also decreases. Okay, wow. So this kind of basic thing we have to take. And then suppose if you are given, the question is, the what is the question? The decreasing order of nucleophilicity. The decreasing order of nucleophilicity among the nucleophiles. So what are the nucleophiles I will give you? First one, A is SH minus, B is OH minus, and C is NH2 minus. Okay. So which one is having more reactivity like that? Okay. So as I've told you, in the periodic table, from left to right, the electronegativity increases so that the tendency of donating the electron decreases. So which one is having better nucleophile? Which one is here? You can find out. Okay. So here the first option is SH minus. The second one is OH minus. Okay. So you can consider that. So nitrogen, then oxygen comes. You know that basically from the left to right. Okay. So nitrogen, this NH2 minus is, this NH2 minus is more or better nucleophile than OH minus. Okay. So as we go down the group, the size of the atom increases. Okay. So its effective nuclear charge also decreases. If the sizes increases, nuclear charge, that is the nuclear force of attraction between the outermost, orbit is decreasing almost. Okay. So because of which its tendency of holding the valence shell electron also decreases, or tendency of donating the valence electrons increases thereby. So we can give which one has the main order. So we can write. So SH minus down the group. We usually known as down the group. What may happens? The atomic size increases. what is increasing? The tendency of donating electron also increasing due to the decreasing nature of nucleophilic attraction or nuclear charge, we can say. Okay, so SH minus has the greater, it is better nucleophile or greater nucleophilicity when compared to NH2 minus. When compared to NH2 minus, OH minus is less. Okay, it is having less nucleophilicity. So this is very important point you can come across. Okay, so this might be asked. So apart from your book questions, I'll explain you. You might be asked this. Okay. So in general, you'll be given some questions. Okay. So what is an electrophilic substitution reaction? Okay. Take down this electrophilic substitution reaction. What is electrophilic substitution reaction? So I will explain it. So what is meant by electrophilic substitution reaction? Okay. So answer, you can write what is meant by electrophilic substitution reaction. I will dictate, you can write the answer. If a substitution reaction is brought by an electrophile, if a substitution reaction is brought by an electrophile, then it is electrophilic substitution reaction. Okay. So I will give you an example. See, for example, R. Okay. So here the electrophile is going to attack. This is famous example. This R is alkyl group that you know, right? Plus electrophile. We know that if the substitution reaction is brought by electrophile, then it is like this. Okay. So this electrophile is, this one is the attacking group. Due to this Ig is the leaving group. Okay, electrophilic substitution. Electrophile is substituted. Okay, right now, here electrophile is substituted. So this is known as, we usually call this as electrophilic substitution reaction. Okay, so and then it is also known as Friedel-Crafts acylation, we can say. Okay, sorry, this has to be written as. Okay, so then the next question, take down the next question. Are alkenes nucleophiles or electrophiles? This is the question. Or alkenes electrophiles or nucleophiles? Okay. So alkenes consist of electron-rich pi bond. Right? Electrons are loosely held in a pi bond. Therefore, it is a nucleophile. It may easily donate electron. Right? So take down the answer. Alkenes have electron-rich C to C double bond. That is the pi bond. Electrons are loosely held in or loosely packed in pi bond. So therefore, it is a nucleophile. So alkenes are nucleophile. Then, are alkenes nucleophile or electrophile? We know that alkanes consist of strong C to C bond. I'm talking about the alkanes. Alkanes consist of strong C to C bond or C to H bond. They are non-reactive, stable compounds. So neither a nucleophilic or nor electrophilic. Okay. So alkanes in nature neither nucleophilic nor electrophilic due to its strong C to C bond or C to H bond. Okay. So I'll catch you up in next video. Thank you. Bye bye.